السلام عليكم. تسمعوني؟ تسمعوني؟ الو.
أوكي، كيف الحين؟
ايه هلا، الحين اسمعك تمام.
معليش بس دقيقة. عبد الرحيم سامعني؟
الصوت زين.
أوكي.
طيب خلينا نشوف سلايدات. طب انا حاعرض السلايدات في البداية من عندي. اوكي.
أوكي. I'll stop sharing. You can share now.
يا هلا، حياكم الله جميعا. الصوت واضح؟
أيوة واضح عبد الله.
طب ممتاز. حياكم الله جميعا في لقائنا الأونلاين الأول لمجتمع الشرقية للبيانات. معكم عبد الله بابعير، حكون المستضيف لهذه الليلة، ويشاركني بعد هدير أبو بيضان، وفي مجموعة بعد رهيبة من المتطوعين يشاركون بهذا اللقاء. طبعا ضيفنا لهذه الليلة هو دكتور عتيق صديقي، محاضر بجامعة الإمام عبد الرحمن بن فيصل، وحاصل على الدكتوراه من جامعة ميموريال من كندا. قبل لا نبدأ خليني أعرفكم على المجتمع والمجموعة وأهدافها. المجتمع هو مجتمع غير ربحي للشغوفين بمجال علم البيانات. مجتمعنا هو أحد المبادرات للمجموعة السعودية للبيانات. المجموعة السعودية للبيانات فكر فيها كأنها مدير كبير وحنا نتفرع منهم، الرياض، جدة، والشرقية. هدفنا تمكين الناس البارعين في المجال، وفي نفس الوقت نسعى إلى رفع الوعي المجتمعي في القطاعين الخاص والعام، ونبين حجم وأهمية البيانات في الاقتصاد الرقمي، وكيف أن توظيفها الصحيح يلعب دور كبير في التنمية المستدامة. أهداف المجتمع: خلق مجتمع يستطيع أفراده توظيف علم البيانات في مجالاتهم، وإنشاء شبكة معرفية مجتمعية تسهيل التواصل بين المتخصصين في مجال البيانات والمهتمين في المجال. أهداف المجموعة الأهداف تتمحور حول 3 محاور رئيسية: تفعيل المسؤولية الاجتماعية، وتنمية المعرفة، ونشر الوعي. رفع مستوى الوعي بأهمية البيانات ودورها في كفاءة العمل وتحسين الأداء وتحقيق أهداف الثورة الصناعية الرابعة. أهم برامج المجموعة، طبعا أغلبكم حضر يمكن، أو عدد طيب منكم حضر لقاءات الداتا جيكس اللي تحصل على الميت أبس، كانت تصير في الرياض والشرقية وجدة. وعندنا بعد الفعاليات والداثون تحصل تقريبا كل فترة، وفي فعالية قريبة إن شاء الله بتحصل بالتعاون مع ذكاء، بين ذكاء ومجتمع الشرقية للبيانات، بنعلن عنها قريب. أعلن عنها للمنشآت، وإن شاء الله حيكون في جانب ثاني اللي هو جانب المحللين، حتلاقوا إن شاء الله تفاصيله بتويتر. ومدرسة التمكين هي عبارة عن، تقدر تفكر فيها ككورس مكثف في البيانات. في نقطة وصلنا لها الحمد لله بفضل الله، قبل أسبوعين تقريبا أطلقنا مدونتنا الرسمية. المدونة من مبادرات الشرقية، بس ما هي محصورة للمجتمع الشرقية. هدفها هو زيادة الوعي في البيانات وإثراء المحتوى العربي في مجال البيانات. فاللي حاس نفسه وده يكتب مقالة، كل اللي عليك انك توفر له المحتوى، وحنا بنضبطك بالباقي، والمجال مفتوح للمشاركات للكل. حياكم الله جميعا، وشيكوا على المدونة بعد فيها مقالات رهيبة. طيب، ما ودي اطول عليكم. لقاءنا اليوم ان شاء الله مع الدكتور عتيق. طبعا في زي البوكس الصغير عندكم تحت للأسئلة، اللي حاب يسأل تقدر تسأل خلال المحاضرة أو بعد المحاضرة زي ما تبي. حتظهر لنا الأسئلة، وإن شاء الله بنجاوب على الأسئلة بقدر المستطاع. الحين أترك المايك للدكتور عتيق. دكتور عتيق. هلو دكتور عتيق.
Yes, sorry, my mic was muted. I'm here with you.
On behalf of all the people here, I would love to thank you for accepting the invitation. And the mic is yours, so please.
Yeah, if you can turn on the video, please, option as well for me.
Okay, I'll stop sharing and.
Okay, so can you see my screen, Abdullah?
Perfectly.
Okay, Assalamu alaikum, everyone. First and foremost, I really would like to thank Sharqiyya data community, especially the organizers, Abdullah, Hadil, and all on their team. I really feel honored, and so I have to start with a humble thank to the whole community, the organizers, and everyone here. Okay, so before Abdullah, I cannot start my video. If it's okay, I can go without it.
No, so Hadil has the control, so she can.
It's okay. It's your choice. Okay, so before I start, I just wanted to mention that I want this session to be really active, really interactive, just like in face-to-face setting. So of course, we are going to have a Q&A session at the end, but during the talk as well, I really wanted to interact with you. So I'm going to suggest that, if you can keep your chat box open, and hopefully, inshallah, I'll be able to make good use of this. And I'll be interacting through this chat box. And if you're new to Zoom, you'll find the open chat option, at the bottom of the screen. Now, coming to the talk, I'm going to talk about success determinants and the next revolution in data science. Why I picked those topics and so on, I'll come to that. But I really wanted to start with, so I really wanted to start by sharing my background. I hope, because I wasn't able to follow Abdullah well, so very quickly, my PhD is in operations management, and my background is in operations research, operations management, with an expertise in decision modeling and large-scale optimization. But more importantly, I wanted to know your background so that I could pace my talk accordingly. While I go there, I really wanted to point towards the bottom of the screen. This is like the agenda. You will be following agenda of this talk, at the bottom of the screen. We are already into the background. And after that, I really wanted, in the introduction, I really wanted to tell you my motivation behind picking up this topic. And this is where I also wanted to set up ground for the next section. So I'll be sharing some data with you. And that data will be using it, for our next sections as well. So coming back to the background, I would really love to see, if I could, I'll be really happy if you could quickly tell me in your chat box your academic background, like if you're from MIS or computer science or computer engineering, stats, maths, that would give me a very good idea of, how I'm going to conduct this talk. So, okay. I see one computer science here. So,
Doctor, you can now start sharing your video.
Okay, sure. It still says, Adil, you cannot start your video because the host has stopped it. Oh, I should be looking at here. I'm a master's student. Okay, computer engineering, MIS, computer science, MIS, applied maths, information. Thank you, everyone. I can see, mashallah, from accounting as well, computer engineering, petroleum engineering. I'm really happy to see such diverse audience, finance, and okay, let me start my video. Are you able to see my screen, Adil?
No, Doctor. Share your screen again.
Okay, I'm going to share my screen again. Sure.
Yes, now we can see it.
Okay. Okay, fine. So deep learning information systems, mashallah, very varied, wide audience from PhDs even as well. So high school to PhDs, excellent. Now, if you could quickly tell me, add to that operations, I really like that because that's my area. So if you could quickly add to that, if you have any experience, on data science projects, maybe in terms of numbers of years or type of project like data management, AI, like stats or something like that. I think I saw some of them talking about deep learning and some of the other things. So, okay, data analysis. If others could add in as well, some areas they work in. Okay, excellent. So I have now a very good idea of, what kind of audience, mashallah, very varied audience, ranging from some very experienced people to some new entrants as well. So that is just great. So I'm going to now I'll come back to my talk. And I'm going to start, I shouldn't be saying this, that I need to sell data to you. I mean, the importance of data to you, but we all know that data, how important data has become these days. People have started weighing it against all like valuable things, against oil, against gold, which is all fine. I think I don't have to tell you that data, it has become so important for businesses, for organizations, for governments, and so on. So I need to move on from here, and I really wanted to first set up the ground for our talk on, the success determinants, where I'm going to talk about something called logical fallacies. So on your screen, what you're looking at are some data sets, and I would especially love to hear from the relatively younger lot. You're looking at some data on your screen. So there are 3 graphs, A, B, and C. Each one is carrying 2 time series. Time series is like, where you have data over time. And if you can just look at A, on your left top screen, you'll see graph A, which has 2, black and the red one. I really wanted you to help me analyze this data quickly, in the sense that, do you see, I'm trying to find if there's any relationship is there between the two. So I really wanted to know if you see any relationship. Maybe if I can guide you to a more precise answer, I'm looking for whether there's a strong relationship or a weak relationship, a positive, negative relationship. Positive means like if one is going up, the other is going up, and vice versa for the negative one. So if you can quickly, okay, you see a strong positive. I see Narjis saying that strong positive. Others? Is there any other one? Okay, strong positive, it seems like there's a strong consensus here. I'm not going to go through all the examples, but let's just look at C as well. If you can do the same for C, do you see, what things do you see in C as well? Is it like the same strong positive or strong negative, weak negative? What kind of relationship do you see here? Yeah, fluctuating. Maybe weak, but do you see in terms of positive, negative, do you see like one is increasing, the other is decreasing? So how do you see about that? Weak, okay. So weak, negative. Now, in the last 5 years together. Now, there was a purpose I was asking you these questions. Now, I'm going to hold my comments back till I reach the section of where I'm going to discuss the fallacies. There are some issues that I see immediately being raised here, and I really wanted to come back to this slide. But as a food for thought for all of you, I'm going to ask you to look at some additional information that I'm going to reveal now. And then I'm going to ask you to look at what your responses were. So if I'm going to reveal this additional information to you about this time series, let's look at A. The black one is the time series showing computer science doctorates awarded in the US. And the red one says that revenue generated by arcade games. And if you look at C, the black one is number of people killed by venomous spiders. And the red one is the number of spelling bee winners. I'm sure you can see where I'm heading. And if you look at even the third one, you'll see oil imports from Norway to US compared by number of drivers killed by train. So I'm going to ask you to think about it. And I'm going to come back in a couple of slides after, but I want you to keep that in mind. Okay. Now, we are all passionate about data science. We really think that it is doing magic to businesses, bringing a lot of success. But there are some ground realities we need to look at. These ground realities, maybe you do not like a lot, but here is a 2019 excerpt from a 2019 Forbes article, which tells us that, in 2016, for instance, there was 60% data science projects were failed. And the numbers are only getting worse. In 2017, they rose up to 85%. And that doesn't even include the AI projects. AI projects, they say it's like every 2 out of 3 projects are failing. But it doesn't mean that the data is losing its value. No, it's still there is still a consensus that data is very important. It holds the key to so many things. But something is going wrong. And you can see, in the other example at the bottom of the screen, that it says that in another study, they're suggesting that only 20% of data science models and analytic models are being implemented in the industry. So this sounds really alarming, isn't it? And so the leaders in the industry have already started to see, why such a large number of failure rates. And many fingers are pointed pointing towards different things. And of course, a lot is being said about the model development itself. And I'm sure people from stats, if some people from stats are here, they must know this very famous saying that all models are wrong, but some are useful, which essentially is saying that models are fine, but they are never able to capture full reality. So they're all, we strive for is to get closer to reality. But the same leaders are saying that because of missing a lot of things during model development, things are going horribly wrong. And there's a very famous data science leader. I just took his tweet even like a couple of days back. I think it's 7th of April. And he was, you can see from his tweet, the frustration coming out of him. He's saying that all models are wrong, but some are completely wrong. Some scientists are making same mistakes in communicating COVID-19 models that they did with the climate change models. So there is something that is on a bigger scale that has to be looked at, something that has to be fixed. And so people in the industry are pointing towards various dimensions. Some people are talking about technical aspects, what's going wrong on the technical side. But because I expect you to be attending a lot of courses and a lot of workshops, even full degree programs, I really don't want to go into the technical details. And we have audience from other areas, like I saw finance and I saw some other fields as well. So I really wanted to point something which I expect not being discussed a lot, but they are extremely crucial, and they must be contributing a lot into this failure statistics that we saw. So I'm going to start discussing not all of them, but some of the major what is called logical fallacies, not the technical issues, but the logical ones. And if you go back to the graphs I showed you, and if you recall towards the end, I revealed to you some additional information about the things. I'm sure you could see that, why are we even comparing, people killed with venomous snakes with spelling bee winners? There's no point comparing, right? But you could also see that there is a strong relationship between these things. So here comes our first logical fallacy. And you can see it on the top here, that correlation doesn't mean causation. And by the way, for people who do not know correlation is like a statistical, there are statistical measures that try to somehow determine the relationship. But even if there's a strong correlation, measure, the number is showing strong correlation, I'm trying to suggest to you is that it does not necessarily mean causation. For instance, you're looking at an example on the screen. If there's rain, people always bring their umbrellas. But if somebody implies from that umbrella causes rain and then opens an umbrella to hoping that there's a rain, you can see that it's a completely wrong assumption. Here, somebody is mixing causation with correlation. So correlation points towards possible causation, but not necessarily the causation. So it is something very, very important. Now, causation is a is something that takes a lot of time to understand. So I really encourage you to go to internet and look more about causation. But what I'm going to tell you is that direct causation is very easy to understand. Like, there's rain and so the floor gets wet and, the summer comes up and there's more sales for soft drinks. That direct causation is understandable, but where causation becomes more tricky is when we have like indirect causation. A is causing B and then B, causing C. So what's the relationship between A and C? It becomes murky. Or you may have a scenario where A, B, C together in a very complex way is causing D. So I really want you to look at the concept of causation and try to separate these two things, correlation and causation. By the way, before I go forward, some fallacies belongs to the early part, model development, some analysis, and some even at the consequence stage. So you can look at where we are. So I'm going to move on to the next fallacy. And by the way, the last one, the main implication is that, if you have, for example, I'm going to go back for a second. If you have multiple variables and just based on correlation, you develop a model and there's no causation, it essentially means that you're developing the wrong model. And, the remedy is basically, the solution is to make sure you establish causation and then include only those variables which has a strong case for causation. Now, moving on to the next one, and this one, which is called cherry picking data, cherry picking the data. So it is rooted in a human behavior called motivated reasoning. Motivated reasoning is like, from your cognitive bias, you before you do anything, you have a liking towards something, so you want that to happen. And if you don't see that in the data or, the output of the model, you become uncomfortable. And what you do is, there might be a tendency to pick the portion of data which is kind of proving the point. So I picked up this data from internet about global average temperature change, and you can see the graph above. It is showing, I think you can see easily that it's an increasing trend. The temperatures are getting higher and higher. But if imagine a person who's not a climate change advocate, the person is from the other camp. So there is a tendency that person could pick the data which might not show this increasing trend, the graph below. And then you can imagine if we develop two models, how different the results would be from the two models. But when I say that, you should not be cherry picking the data, it does not mean that I'm saying that you have to include all the data all the time. There are situations where you have major, what you call structural changes in the data. There's a huge policy change by government, which makes the behavior irrelevant, like we are having this pandemic situation, right? So if you're trying to model energy demand pandemic based on our historical data before pandemic, you can see that it doesn't make sense. But the key here is to have transparency, clear assumptions about why I'm picking certain portions of data. So the implication is wrong data, as you can see, means cherry picked data might lead you to wrong conclusions. And the solution is, even if you have to truncate data, you have to take part of it. It has to have a very strong reasoning behind it, but certainly not motivated by personal biases. Okay. Next one. This one is an interesting fallacy. It's called personal incredulity. And because of that, as a consequence, there are issues of explainability and the trust. So personal incredulity is like, we are talking about common sense. You always have you have a sense about, what should be the output from my data. And if that doesn't happen, what you try to do is first try to explain it. But if you can't explain it, the natural tendency is to build a lack of trust in your data. You might be thinking, maybe I haven't have the full data, maybe something is wrong with the model. So there's an element of lack of trust, that builds up. And the result is, with the lack of trust, it is as simple, for example, if your team or your boss does not have a trust in the output, he'll say, I'm not going to use it. Now, you can see even Elon Musk, is a famous technology person, but look at his comments about AI. He's asking about regulating it, implicitly saying that, look, I don't fully trust it because I can't explain all aspects of it. So indirectly saying that, we need to stop it somewhere. Now there are two graphs you can see on the screen, both for the same problem. Both graphs are giving you data for bad debt. People default on their loans, and this is being plotted against their age. So if you look at this right one, for example, age around 30, there are 15% of the people who are defaulting on their loan. They are unable to pay back their loan. And like 25 years, it's around 20%. So these, and the same graph, it is for the same data here. I want you to look at both the graphs, and can you tell me if the right one or the left one, which one is making sense to you? Which one, immediately looking at it, if you feel that, the right one perhaps is making sense, or the left one, or maybe both, whichever way you feel, I'd love to hear, what you feel about these graphs. In the chat box, please, if you can. Okay, right one. Ahmed says right one, right one, right one. Okay. That's the point I'm trying to make. It seems like there is a common sense pointing towards what is making sense and what is not making sense. That's exactly the point I was trying to make. Everybody, which I was expecting, honestly, that you'll all be pointing towards right. And why was that? Because I think you are able to explain what's going on. The key lies in the explainability of thing. So if you see that, with the increase in age, left is seasonal or time-based. It's actually by age, so I'm going to come to this one as well. But if you look at this one, you're kind of implicitly, what I can see from your reasoning, you might be having your reasoning in your mind is that people, as they grow, they are more mature, they are more financially stable. So it is expected that, they are able to pay back their loans. I guess this is what you have in mind. But if you look at here, like with 20 years less, maybe default but higher, and then coming back again, the left one, and then it's so hard to explain, right? And so that makes you uncomfortable because it is becoming hard to explain. So this is called the issue of personal incredulity, which is where it's not appealing to your common sense. Now, there could be multiple reasons you need to be aware of, and I'm going to talk about one of them in the next slide. So I'm going to hold it, but I'm going to tell you that at least the consequences, people may not use it if they don't trust it. What you can do, at least at the technical level, is to avoid what is called overfitted models. At least people who are working in decision science know about this overfitting of models and the consequence of that. If you try to overfit too much, the model tries to capture, have more points into it. And that, this line, the trend line becomes like, very hard to explain. Second option you can use is to do what is called model ensembling, which means that rather than relying on one model, one kind of model, you go and develop multiple models from different areas like statistical models and AI models and so on, and see at least, it is better than the last time. Even if you're still not being able to explain, you can at least say that, both different models are kind of showing the same result. But more importantly, and I'm going to talk about more on the next slide, is to talk to subject matter experts. Eventually, what will work for you is the explainability thing. If you are not being able to explain what's going on, why your model is behaving in this way, I really doubt, people will be using it. So eventually you have to spend time to really understand why. Maybe this one will make sense, who knows. Subject matter experts will be able to tell why this complex behavior. So, so these are some solutions. So moving on to the next one, we have what you call false dichotomy. And again, this goes into human tendencies, human behavior. We are talking a lot about human behavior. So this one is also, it is pointing towards something very interesting about human behavior. We, by nature, when we look at a problem, humans, we try to isolate the problem, try to make it simple so that, we could understand it better. And by doing that, we are running into this problem of simplifying things. And, and this is, by the way, the consequence part. We have run our data, we developed our model, and now we are making decisions, policy making, that part. So we are looking at the expected outcome of our models. We are making decisions based on our model, and we are suggesting that only, this and that, very few things can happen. But what you experience in many situations is what you call the Cobra effect, which is defined as actions leading to unintended consequences. I'm going to explain it by a very interesting example that you can see on the screen. Englishmen, they used to rule subcontinent, and this story is like, it goes back to 1800s. And in one of the cities, the government faced there a very interesting problem that there were a lot of cobra snakes. And it was causing a lot of problems. So the government thought, it's a simple problem. There are cobras and we have to kill it. That's how they looked at it, in a very simple way. And they factored out all other things. So what they did was they said, let's create a scheme of cash reward. Anybody kills a cobra will pay, 10 rupees, 20 rupees, 100 rupees, whatever, some reward. And they thought, fine, it will, people will take care of it by themselves. But guess what? Unintended consequences. People saw an opportunity in it. That, there are cash rewards. Let's start cobra farming, which is honestly, a very interesting thing that has happened. So they started cobra farming so that they could have more cobras, so that they can kill more cobras and have, even greater reward. And then government saw, okay, what is going on? Maybe, I'm not sure how, we can certainly look at it about COVID rewards. I'm not sure what we have to think about the policy. Anyways, so the government stopped this scheme immediately. And you can imagine the end result. There are even more cobras than before. Now, this goes back to how humans think. We are normally, we go to what is called reductionist thinking. We try to simplify things, create boundaries around our problem and make things simple, but it doesn't go that way. And if I go back here to the slide, this one might have to do with some social complex thing going on. So what I'm trying to tell you here is that you need to learn a little bit about something called systems thinking. Systems thinking asks you to look things in a more holistic way, more deeper way that includes, a lot of other things, a lot of other stakeholders, their behaviors, how complex their interactions are with each other. So this allows you to think more deeply and more holistically. And again, it's an area in itself, systems thinking, but I would really encourage you to explore, make note of this area called systems thinking. And, if you could read on that, inshallah, you'll be able to see some really nice new way of looking at different problems. Okay. Now, while all the other previous ones, fallacies, if you search on internet, you'll find a lot of them. You'll find a lot more of them, Texas sharpshooters, and, you can name many fallacies, but this one is generally not there in the literature, but I feel that this one is a very crucial one, and this is called the curse of averages. Now, before explaining the curse of averages, I really wanted to ask you a question. When you build a model, what are you exactly trying to do? And again, I would request you to respond in the chat box. I really want you to know, when you're building a model, what exactly are you trying to capture? What are you trying to do? What exactly is your objective by creating a model? You have the data in front of you. You can see those things. So why exactly develop a model or so-called fit a model? I know it's solving the problem, Hussein, is like the bigger thing. Behavior, what do you mean by behavior? Capturing the behavior. Okay, Murad. So you're saying that find out a pattern. Okay. Okay. Classification of data, extract features. Okay. I think you're all pointing towards something. Yeah, the pattern. What you're trying to do is to pick a pattern out of the data, isn't it? And when you say pattern, you really have to understand finding relationships, rules, variables. That's very nice. But you have to really understand what that means at the philosophical level. When you, okay, let me see. Oh, okay, I'm going to, thank you, Abdullah. I'm going to set it to all panelists and attendees. Okay, fine. I'm going to ask you to think about when you say patterns in a very philosophical way. Yes, to justify the behavior of the data as well as predict the feature. You're all pointing towards that, but let me summarize in a very nice way. When you say pattern, you are looking for average behavior in the data. You're looking for average behavior in data. When you say pattern, what exactly is a pattern? Which most of the points are following. Yeah, you can call it trends. Trend is a pattern. Yeah, it's kind of a pattern. Seasonality is a pattern. But pattern is something which bulk of the data is following, isn't it? And that's what model tries to capture. But that might be really problematic in many cases. Yeah, seasonality trends, all these are examples of different patterns. But by pattern means it could be trend, seasonality, waves, some more complex one, somebody mentioned about clustering or something, but patterns, it could be nonlinear patterns and so on. But many a times when you're trying to look for patterns, what matters most is not the pattern, but what is outside the patterns. I'm not sure if you heard about black swan or gray rhinos, these notions. These are like what you call low probability but high consequence events, LPHC events. Low probability means the occurrence of such events are very low. Black swans are those events which you can't even predict. The black rhinos are which you can predict, but you kind of as a collectively choose to ignore it. Yeah, they are, Ravan, they are like outliers. But many a times what matters most to your problem is outliers, not actually the bulk of what the data is doing. And I'm going to give you the example of risk. Many a time, think of the current situation, pandemic. I'm like running the resource planning in medical supplies for the government, and I'm planning to plan my medical infrastructure supplies. I asked for the data for the last 30 years for Saudi Arabia, and I looked at that, and based on that, I created my emergency services. I created my number of masks that I need to keep in the country. The famous N95 mask, and the ventilators and all those things. But guess what? In the pandemic situation, where does that planning go? If we are just looking at overall pattern of the data, you see that it might not work here at all. So that's what curse of averages is. Sometimes we have to be cognizant of the fact that it's not the averages we are looking at, the average behavior or pattern, it is something outside. So the key is to know your problem. If you don't know your problem well, then you might be suffering from the curse of averages. So these are some fallacies, and I discussed, the implications of those. And by the way, going back, you can imagine the implications. It might means a total disaster. Yes, understanding of problem is it is. That's a big key, and I'm going to talk more about it in the next section. So we have discussed some logical fallacies. And I really would encourage you to keep those in mind, learn more about it. Just a small talk with 15-20 minutes discussion on each one of them is not sufficient. But I've tried to open the door for you to know more about it, learn more about it. I'm especially talking to the younger ones, so I really apologize to the more seasoned people. I can recognize some names, very seasoned names in there. So my apologies if I say, I'm asking you to, learn about something which you already know. Anyways, so the next phase of our talk example case. In this part of the presentation, I really wanted to present to you a DS project that I worked with someone. And I really wanted to show you in the context of what I say end-to-end solution. I feel that the big point missing in the data science project is this end-to-end thing. We are somehow starting but leaving it somewhere before where we should end the projects. So we need to go further to make it really worthwhile. So I'm going to show you this example, and what I'm trying to do is to show you building blocks, and it's basically my view on that. So I'm going to show you some building blocks, and by showing you that building blocks, I really wanted to highlight that some of those building blocks are there, but they are quite undermined in current most of the decision science projects. They are undermined, they are not being given enough emphasis on it, and that might be causing a lot of problems. Plus, I'm going to talk about some of the links towards the end of this chain that I feel is completely missing from the data science landscape. And completely missing means like, at least like 95%, 98%, are not even thinking about it. And this is where I feel the real key holds, where the real value comes from that particular building block. And unfortunately, we as data science community is just going close to that and leaving there. So this is where I feel that the next revolution holds. So essentially, I'm going to walk you through this example, and you can see, the whole thing that I'm trying to explain to you. So I'm going to start with the scenario that we worked on. So the problem was essentially of an oil supply chain. That's my primary area of research. I work in oil transportation as well as oil economics. So and it is thankfully more related to Saudi Arabia. So I'm hoping that it might interest you as well. So I think all of you are aware that global oil sources are quite limited. And one of the major sources, of course, Middle East, and within Middle East, the biggest source is Saudi Arabia. So around 36-37% of the global supplies originate from this region. But as you can imagine, the real users are all over the world. And in fact, the bulk of the users are the farthest from this place. Like US, which takes quarter almost of the supply, is like the farthest place. Europe 17%, and Japan 14%, China, India. You can see that they are all over, which essentially means that this oil has to be transported to far away distances in bulk quantities, essentially very large quantities. And in order to do that, the only real solution, except for pipelines in certain situations, is to make use of those super oil tankers, which in technical language they call them VLCC or ULCC class tankers. VLCC means very large crude carriers. So they are like huge ones, like they start from 200,000 kilotons capacity, and they go even up to the ULCC, the ultra large ones. They are like 350,000 tons and more. Now, these assets are very unique. They are extremely expensive, extremely expensive. If you want to buy a VLCC tanker, the starting price is around $120 million. So they are really expensive. And not only that, their operating cost is outrageous. If the tanker is standing still, each day it costs you $15,000-$20,000 by just to keep it stand still. So it is a very expensive asset. And I'm going to show you something which makes it even more critical, that in order to make use of this asset, look at the amount of days it takes for a tanker to go from, let's say, Saudi Arabia to US, Gulf Coast, Gulf of Mexico. It takes around 40 days. It's like 12,000 nautical miles. These tankers, of course, they move slow, 13, 12, 13, 14, 15 knots. So they take a lot of time. So imagine such an expensive asset, one asset engaged for over 40 days one way, and like around a month back. So this is a very expensive asset, and even for a size of company of Aramco, they are critical assets. And by the way, Aramco when we did this problem, Aramco used to have a subsidiary called Vela, We used to have like around 15, 20 VLCCs plus some other things that I'm going to discuss. Now they have sold it to Al-Bahri, you know, Saudi shipping company, but the problem is still the same, whether it is handled by Al-Bahri or by Aramco. So for that problem, I think I've spent a lot of time explaining you the problem, and I'm going to engage with you again. Okay, sure. I think, you know, Hadil and Abdullah are looking at it. Somebody says that you want to record, but I think it says it's recording. So inshallah, Wasam, you'll be able to see it again as well. So coming back, so for that problem, you are looking at two data sets. You're looking at two data sets. The first one at the top, you know, the line, the black line you're looking at in the top graph is actually the amount, you know, monthly amount that you are shipping, exporting to from US, from Ras Tanura, Saudi Arabia to Padwan, US Gulf Coast, Gulf of Mexico area. And yeah, it's a huge amount, but main thing you want to see is the fluctuation in it. And the vertical bars that you see down there, you know, and the scale is on the right side, is the number of tankers needed. And by the way, this is not number of total tankers needed. This is number of chartered segment. You just hold for it. I'm going to explain what do I mean by it in a second. And the graph down there is what you call charter rates. For those people who don't understand charter rates, I'm going to really simplify things for you. Charter rates are like taxi rates. You go out, you negotiate, and based on the situation, the taxi driver says, okay, I'm going from here to Dammam, from Khobar to Dammam, they say 30 riyals, you know, right? So if there are more people standing, he may be asking about like say 35, 40, so it fluctuates. So it can go up and down based on the requirement. So down what you're looking at are historical charter rates. Now, I need your help, all of you. I really want, you can see that it's a complex problem. I'm the fleet manager here, so I really want your help. I'm really seeking your help. So you have the data in front of you. Can you suggest me something that could make my life easy? You know, something that you can, you are all data scientists, right? So can you do something that will allow me to simplify my work? So can you suggest something what I can do with this data? Again, you know, in the chat box, please, you know, responses in the chat box. Can you, basically what I'm saying is you have the data and I don't know how this data is behaving. So is there something you can do for me to, that you can suggest? For example, let me give you a hint. Can you help me, okay, optimize your tankers based on spot charter? That's a very good one. But I don't understand the, okay, let me explain the problem again. We have, that's exactly, Bandar, you know, I really like your response. I intentionally, Ahmad, very good, very good. That's the response actually I wanted to see. When you say I don't understand, that's exactly the point where I wanted to see. So because I'm getting this response, I'm going to go to the next slide. And then I intentionally did not explain the problem very well. Okay, so this was the response I was trying to look, you know, predict rate, look for develop predictive models and so on. But I really love when really loved it when I saw you when say we don't understand the problem. That's the key to doing the thing in the right way. Now, this is the building blocks you are looking at. And I'm going to come back and I'm going to Bandar and Ahmad, I'm going to answer this thing more properly to you again. What is missing in this whole end-to-end data science solution are several building blocks. And let me just show you what the whole building block, all building blocks look like and what are their flow, and then I'm going to come back to it. The first one to me is real understanding of business need. What are you trying to achieve? Secondly, you know, the most important one for you to understand is what is the problem? You need to really understand the structure of the problem. And then you look for the data that you actually need to solve the problem. What I did on the last slide to you is actually was to show you the data, and that's why you got confused. But you might say that let's fit a predictive model. And that's what I wanted to tell you, that no, it's not the right place to start off with. You really need to ask me What is the business problem? What are you trying to solve? And that's what you exactly asked. And then you have to ask me what is the business problem structure that you're trying to solve. And then according to these two things, then you ask me, for this problem, I need this data set, okay? And then we create a solution for it. And then something that, you know, is a make and break for the project is, which is called value creation. You need to answer where is the value being created from this whole project, okay? So now let me try to simplify things and try to answer Ahmad, Bandar, and everyone out there in a much better way. I'm the fleet manager. You know, I'm working for Saudi Aramco. In fact, you know, if you can just hold off for a second, I could explain it a little bit better on the next screen. So I'm going to do it incrementally. So I'm basically the fleet manager, and I'm facing huge uncertainties in demand and charter rates. And I don't know how to manage. You know, sometimes I get a tanker on charter and it causes me a lot of financial failure. So I really wanted to manage my risk, and still I'm going to explain this part on the next slide in more detail. So I really need to understand how charter market works. And then I really need to determine that I need demand and charter rates data. And then I'm going to create a whole suite of models. And by suite of models, I mean, say by saying is by suite of models, I mean that some part I need to predict, and then some part, you know, once I predict the behavior of demand and charter rates, I need to take a decision. Normally, the point that I'm trying to make here is that in normal data science, there's a huge focus on predictive modeling. What you do is you understand the problem and you look for data and you try to model and predict the behavior of the data. But then most of the data science project just stops there. The real business problem or business need is to take decisions, some decision. And when you say this is going to happen in the demand and this is going to happen in the charter rates, what you are missing is making a decision on how many charters should I buy, how many charters should I charter, or tankers should I charter, and so on. So these decisions are missing. And I'm going to talk more about it, you know, on the next couple of slides. And of course, you know, eventually I really want to manage my risk. So let me go to the first part, explaining what my business problem is, business objective is. I'm facing a lot of uncertainties as fleet managers. The demand is going really volatile. You know, 1 month, my demand is for 10 tankers. The other month, the demand goes up to 20 tankers, and then it comes down to 15 tankers. So the demand is really varying a lot month to month, you know, so it becomes very hard for me to plan. And the spot rates for the tankers are also, they are going crazy. I still have a feeling that you don't understand the concept of spot charter rates and the charter rates. So you should ask me, you know, what do you mean by spot charter rates? So the objective is really to manage the financial risk and avoid big disasters. I know the problem is really new to you, but let me explain a little bit more. A company like Saudi Aramco, one thing they can do is to buy a lot of tankers, 30 tankers, 40 tankers, and then say whatever demand comes, we have enough fleet, right? Do you understand what I'm saying here right now? I think I'll be better off if I see more responses in the chat box, because I know suddenly, because it's a very specific problem, so not everybody is following it. So when I say it, so it will be nice if you could respond in the chat box. So I'm saying that a company like Aramco, one option for them is to buy a lot of tankers, 20, 30, 40, and whatever the demand comes, they just fulfill it. Do you all understand this part? That, you know, Aramco just buys 30, 40 of those tankers. So the other option is for another reason. You know, the tankers I told you are very expensive. Even a company of the size of Aramco cannot afford tankers standing still. And if you look at, you know, the demand data, I'm going back, there is a huge chance by using this policy to buy a large number of tankers that many of those tankers are standing still in many periods, which means that it's a huge burden on Aramco, which essentially means that it's a huge financial risk. So they don't want that to occur. So that's like, you know, one thing, how to deal with the situation when you cannot afford to have a very big fleet. what you do is to go to charter market, and charter market is like taxis. You don't have enough cars, you keep, like 2-3 cars in home, but if you need more cars, you go and find a taxi to go. So charter market is like those taxi and rent-a-car services. So spot charter, the first one, is like a pure taxi. I need one tanker. I ran out of tankers in my fleet, and I have to make a delivery. So I go to the open market. Tankers are just next to Ras Tanura. Lots of tankers standing outside waiting, like taxis. And I say, okay, what's the charter rate today? They say $50,000 a day. They say, okay, fill up the crude and send it. You're all following me? What is spot charter? So this, I just need it for one trip. So that's like spot charter. But now you can see that that's a risky thing, because charter rates just go crazy. If you look at, I'm going to point you to some data points here. This one at the top right here, if you could see, it says charter rates could be around $353,000 per day. It might go as high as this one per day. And I told you it's a 40-day trip. So you can imagine how big that one trip would cost to Saudi Aramco. But there are other days, when the price is very, very low. So it's a very risky game. So that's what you call spot charter. There are less risky charter options, and they are called time charters. Time charters are like rent a car. I know I'll be using this tankers at least 2 times, 3 times. So rather than obtaining it for one trip, I charter it for 3 months, 5 months, 8 months. And then that tanker is available with me, and I use it for that period. And then once the period is finished, I return the tanker. So that's like time charter. I'm not going to go into options, but options are like I saw some finance people. So this is like financial options, where you don't go into contracts, but you keep the option of going in at a certain price. I'm not going to go in there. I don't want to complicate things at this stage, but you understand the problem. We have a fleet. Part of it is owned, few tankers, but part of it I'm managing through spot charters and time charter contracts, according to my scenario, according to my demand scenario, according to my charter rates. So what do I need? We understand the problem. The problem is I need to keep my fleet enough tankers using my own segment and chartered segment, and so that I don't have any big financial risk. So I collected this data called demand data, charter data, and the vessel data, vessel availability, near my port. And then I took this and created predictive models, because I really need to know in my future. I'm planning for 1 year. So I really needed to know what's going on during the next year. I really need to predict what's going on in my demand and charter rates. So I create a predictive model, but this is where decision science stops. That's the point I'm saying. Whether I use machine learning model or a statistical model, most of the data science just stops here. What I'm trying to suggest to you is that there's a crucial step after it. All these predictions and data must go into a decision model. Right now, you're leaving it to a manager. The manager looks at the demand patterns, charter dates, and decides, okay, I need 2 tankers in this month and 3 tankers in that month. That is fine, but the problem is too complex for anybody to handle. So what you do is you try to convert the whole problem into a mathematical model, which means that the whole problem structure is now represented as equations. I'm not going to go into equations, but I want to see you as a black box. So this box represents the head of the decision maker. All the planning rules go into this box, all the planning rules. I hope you're following me, everyone following me. So it is a box in which the whole planning rules go in there. And, all the predictions go in there as well. Are you all following me? So quick response in the chat box, please. Okay, so then this box if you somehow process this box, the output is the decisions that the decision maker has to take, which is basically, how many contracts you have to do for spot charter, for time charters, and so on. So this box is the missing block in the whole decision science landscape. This is what I'm suggesting. Now, I'm going to quickly go and show you. This is actually a symbolic form. Actually, it translates This model translates to equations like this, which you put it in a software called optimization solver, and the optimization solver solves it for you. The output is the actual decisions you have to take. Okay, so coming back to the presentation, I know it is this is perhaps one of the reasons people are staying away from this thing, because it is still a little bit too complex for people to handle. But I'm going to tell you that same was the case when a few years back, when we used to talk about machine learning and artificial intelligence. And when I first took a course, my master's was from King Fahd University. So the first course I took, the instructor talked about neural networks. Now neural network is, everybody's talking about neural networks and deep learning, but it was way back in 1999. So at that time, it was too difficult for industry to handle. But I have a strong feeling that once people get hold of this machine learning and so on, they will eventually come to the decision part. Anyways, so this end-to-end change, you really need to have a clear and implementable solution process. All the steps has to be well connected, well programmed. This is where the key lies. This is where our role as decision scientists become very crucial. We need to turn this concept of data to prediction to decisions to solution. This whole thing has to be well laid out. And for our case, we use different programs at different stages. Some we use MATLAB, and the last box that you're looking at the right side is the model which was solved by a software called Cplex. Now, even with sorry, I'm going to skip this slide. I think it is getting a little bit too complicated. The point I was trying to make on the last slide mainly was that of not suffering from the curse of averages. Our model was taking care of those big changes in prices and demand. So that's the point I was trying to make here. But I'm going to spend a little time on this part called value creation. This is eventually what businesses want. If there's no value, there is no project. Even by creating all those fancy equations and models, nobody would use it. So you are looking at the value created by this project. On the left side is the solution. The light gray ones are telling you how many time charter contracts you need, the black one, how many spot charters and options, and so on. I'm not going to spend here. I'm just going to show you the numbers the managers are interested in. The middle one. There is a risk measure called CVAR. You don't have to understand it. But by using this model and not using the model, if you compare the two scenarios, you can see that our optimization model was able to reduce the risk by in various planning periods. We are going month by month planning. So it is able to reduce the risk by even up to 60%, which translates to with like $15–20 million per month. So it's a huge thing. I'm going to just make the last point here, and then I'm going to stop here for your questions. Whatever you develop in data science, decision model or any other model, it has to be what you call robust. Just remember the word robustness, which essentially means that it should be able to deal with all full spectrum of the scenarios you are facing, which means that, fine, my model is working very nice for this particular problem, but it may not work for another situation. So you just have to test your model rigorously for all possible scenarios. It's just the graph, the down graph, I'm not going to explain again, but it is just showing that whatever be the demand scenarios and the charter scenarios, the model was able to deal with any possible situations. So I'm going to go back here and quickly end my talk here, basically saying that don't forget about business needs. The first question, as some of you asked, that we don't understand business need, please explain it. I don't understand the problem. That's exactly the point you need to start. And once you understand the purpose, you need to understand the structure of the problem, because these two things will go into your models. And of course, you need to know the relevant data, and then never forget about value creation. And mainly, the decision modeling, I know it looked a little complicated, but this is where I strongly believe that the next revolution will come. Maybe not immediately, maybe after 5 years. But this is where I'm really positive that the new revolution will come very quickly. Now I'm going to stop here. and I'll be really happy to respond to your questions.
اوكي اذا في احد عنده اي سؤال في الشات بوكس اللي تحت عشان يجاوب عليه الدكتور.
So Abdullah, I'll be looking at chat box, or people can ask me like through mics.
Through the chat or the Q&A.
Sure. Then I think I'll be looking at the chat box closely.
Okay. I have a question for you.
Yes, absolutely, Abdullah.
What are some resources that you recommend to avoid such fallacies and these things?
Okay, that's a good question, but that's also a very tricky question, honestly, because there are so many resources out there and people can get easily lost, because there are just too many things out there. What I can suggest to you more, okay, I'm going to come back to this model, Sheikha, I'm just going to answer Abdullah and come back to you. What I personally do for myself is to follow people, like I especially like this person called Kickborn. He's an industry leader for sure, and he's a very, very well recognized person. But what I like about him is that he very pinpointedly suggests some very nice resources. So for myself, I follow him on Twitter, and he always comes up with resources that I'm not aware of, but I really am happy to see those resources. But other than that, what I can suggest, yeah, sorry?
Something or only through Twitter?
No, he basically is on Twitter, and the good thing about him is he's not like a typical technical person. He likes to communicate things to people. He likes the people to grow in the decision science field. So I'm talking about Twitter. So if you could follow Kickborn on Twitter, you can see his Twitter handle. If you go there, you'll see, every next day he tells you that, look, this is a very nice resource about learning that thing and so on. But there are a few more things I would like to mention, especially with this pandemic situations, big publishers such as Springer, etc., they have made their resources freely available. I can send you some links later. Like Springer, I know they have made around 400 books on data science freely available to people. Then there are, of course, MOOCs by top universities, those courses with very small fee, $15, $20. And there are even nano degrees, that people can look at. So I hope I was able to answer your question, Abdullah.
Thank you so much.
Sheikha, I'm going to come back to Sheikha. Thank you, Sheikha, for your question. I'm going to stretch my chat box because I don't want to miss the questions. Sheikha, the key to make a good model is, and I'm going to go back to that slide. And I'm going to go back to the slide. The first two boxes that you look at the top holds the key to a good model. You can develop fancy mathematical models, but they can be meaningless if they are not capturing your business need or not capturing your problem structure. The more they capture, the more your decision model to be able to give you better decisions, better results. So that's the key. I hope I've been able to answer your question, Sheikha. So we can talk more about how those models are built, but that's the key. Business need, capturing the real business need and capturing the real problem. And as data scientists, I should not forget that you need to have the good quality, right data sources to back up your model. Okay, thank you, Narjis. Thank you so much. I think I do.
Yeah, Rowan says, is this decision science different than from data science?
Yeah, I see. Okay. There has been a lot of terms being coined: data science, analytics, decision sciences, operations research, operations management. Personally, if there's a very big community called Informs, I'm also a member of that, and they deal with all those people, from all those backgrounds, and they have come up with a very nice term. I cannot recall it fully, but analytics in operations and analytics in OR. Yes, analytics in OR. So these terms are loosely used because some have more emphasis on stats, some have more emphasis on AI, some have more emphasis on decision models. But I personally see that they have a lot of overlaps. So I like what Inform says. Maybe my cognitive bias towards Informs, but analytics and OR try to capture everything. So whether you talk about statistical models or AI or decision models, that's by definition it captures everything there. So terms are interchangeably used. Narjis, yeah, thank you so much. Okay. I'm glad that you have learned a few things. Yes, Abdullah, I'm listening to you.
When I want to choose a model to apply on my data, what is more important, simplicity or the result, even if there is no big difference?
Now I should ask you after this talk, which model are you talking about? Are you talking about predictive models or are you talking about decision models? There are two stages to look at the data. I'm going to go back here and I'm going to show you that figure. Sorry, I think it's in, it's on the other side. You take your data and you develop AI or statistical predictive models, and you use it to forecast your future scenario, right? That's called predictive models. If you're talking about predictive models, Abdullah, the general answer is simpler is better, as a general rule. The fewer terms you use to explain something, to predict something, to fit the data, the better. But when it comes to decision models, the answer is more complicated. You really need to capture the whole problem structure. So if you can capture the whole problem structure, then you're good. If you're missing a crucial problem structure, you're not good. By saying problem structure, it's like a decision maker. So now this box is like your decision maker. So he needs to think about all possible, constraints, all possible limitations that a decision maker is considering before taking a decision. So it has to be more extensive. Shall I move on to the next question on the chat box, Abdullah?
And Nasser says, how do we make sure that our model would perform well in real data?
Sorry, which one is it? Like a name? Can you tell me the name again, please?
Hussein and Nasser.
Hussein Nasser. Okay, Hussein and Nasser. Yeah, I can see his name there as well. Can you repeat the question? I'm a little overwhelmed looking at the chat box and listening to you.
Okay, how do we make sure that our model would perform well in real data?
Again, the question answer is the same. Are you talking about prediction models or are you talking about decision models? I'll keep on telling you to differentiate between the two, because I don't want you to miss the decision model. Well, the answer is it's very complex, even if you're talking about decision prediction models. And when you use real data, you really need to take care of logical fallacies. You need to think about all the technical limitations. And then the point you asked last time, the model has to be simple. And then you have to rigorously test this model to see the accuracy of the model. There are it's not a technical discussion here. So there are ways to test the prediction power of your model. You can say that it is forecasting more accurately or less accurately. So we are hoping for more accurate models, but those models which are simpler as well. But again, if we are feeding the right data into the decision model and the right structure, then the decision model is as good as your data in the problem structure.
Yes.
Okay, so let me quickly look at the chat box, Abdullah. So thank you, Narjis. Thank you, Hussein. Dania. You can share your question anonymously. Okay, Hadil is basically asking that you can share questions. Is data science different than data? Okay, so I think I kind of answered that, data science and decision science. When I want to choose a model to apply on my data, what is more important? So I already answered that question. Rahaf Hussein, how do you make sure that our model would perform well? Hussein, I just need to add more to it. I talked about robustness. It has a lot of testing is essential when either you do predictive model or decision model. You have to test it thousands of times to show that your model is behaving. What I suggest to you is always compare it with the real world. You don't just directly take this model to the real world. You develop the model, and in parallel to your real world, you keep on testing it. See if you would have used this model, how would it behaved, and so on. So basically, that's the thing. Sheikha, thank you so much. Maqsood, I think I recognize a lot of names here. In which areas shall we enhance our knowledge to avoid such fallacies? That's, you may be working in statistical models, you may be working in AI, you may be working, it's fine, it depends on whichever area you're working on. But I want you to, in this presentation, the first part, I want you to not to forget about logical and philosophical issues. This is a big hole where a lot of problems are occurring. People are very good in, programming neural networks and deep learning and running, statistical tests on R and, all those softwares. But where they are lacking is, the logical issues, the issue of causality, the issue of cherry picking data, the issue of, personal biases. So this is where I really, really want people to know, to be aware of, be cognizant of, we need to be aware of those logical and philosophical issues. Also business analytics, business analytics, they are mostly like, they have huge overlaps, all these areas. Okay, Azuddin, I study master in stats, and my question is, can I get a PhD? Absolutely, and you can go PhD in data science. Stats is a huge foundation of data science. So certainly, it will be a very, very good option, Azuddin. Okay, Murad, there is a huge project in Ras Al Khair to build a factory for VLCC adopted by Saudi. How will this affect the model you shared? That's a good question, but look, we have to differentiate between tank transporters. There are lots of stakeholders in the business. Transporters, which runs the tankers, which nowadays it is Al Bahri, Saudi shipping company. Then we have the supplier, which is Saudi Aramco, and then we have the tanker manufacturer. They might be like integrated in the same company, but normally they are different players. Each one have their own roles. The tanker manufacturers you are talking to, Murad, can only work if companies are looking to vertically integrate tankers, like Al Bahri. They want to buy a tanker, then their business would be fine. Or independent tanker, who are running charter market, they can also go and buy. So I guess they know that there is still a lot of demand for VLCC charter rate, but we are facing an LPHC event. What happened yesterday with WTI price and pandemic causing oil demand to just nosedive. So all such businesses are now facing those black swans, if you would like to call. So I hope I was able to answer this question. It's a very big area. But I hope I was able to answer this. Is deep learning more advanced and difficult to implement than machine learning? I guess deep learning is part of machine learning. Machine learning is a overarching idea. It has several things inside it. So deep learning is like a more elaborate neural networks. Somebody who works more in artificial intelligence, AI, and neural networks can better answer this question. But this is what my understanding is. Should we use equations in fleet planning? I guess you're referring to, if you look at the model itself, it uses all the equations. These equations are translating the problem to in mathematical form. So yes, the answer is yes. How can we start step 1 in decision science? You cannot go to how can we start step 1 in decision science? I think you meant data science. I think you need to have a good background in stats. If you're I'm not sure what your background is, but if you are from the other area, you'd like to come to decision science, you need to learn a little bit of stats. You need to know a little bit of math. If you're confident in math and stat, then you can certainly enter this area. Shaukat, thank you so much, Shaukat, for your comment. Bandar, in simple terms, is the difference between decision predictive models only the decision model print or the best outcome? Look, prediction is only helping you. It's not allowing you to take decision. Because what predictions are? They are forecasts, right? You want to see what's the demand going to be in the next month. And this is where I say, the field is lagging. When you say the next month, my tanker demand is going to increase, next 2 months, it's going to constantly increase. So, as a fleet manager, I should be asking, I need to make a decision, how many tankers should I charter? That's the decision I have to take. And this is where, prediction stops. Prediction just tells me that something might increase or decrease, but as a planner, I need to take decision. But the model that I'm talking about will help you take this decision. How many tankers, when I should charter, the time and so on. I couldn't find your Twitter account, Sheikha, so I'm going to write it here. It's ATIQE, it's 1619. So that's basically that's the one. Okay. Badur, University for Big Data PhD. There are honestly lots of them. You can contact me personally if we really need to understand what's your focus. Are you focusing more on stats or AI, or you're into decision sciences? The answer to that. But you're more than welcome if you have a particular thing in mind.
Dr. Badur also asked for recommendation for courses to start in this field. So if you could recommend some topics, let's not just mention specific courses, maybe just topics that would help people to start in this field.
Yes, I think I mentioned about stats. Stats, probability and statistics holds the key to everything. It's not the only thing, but the current data science, what people call current data science, I think you really need to understand the probability and statistics. Those are like the basis for it. So you really need to go and learn this, stats and probability. Okay. The scientist he mentioned or the speaker, yeah, it's Kirk Bond. You can look at my my slides and you can see it from there. Could you provide me with okay, so thanks. So thank you everyone. I'm still here and I'm still willing to answer more questions. So I'll be really happy to respond to people.
There is some question here. So there's someone who already have a background in statistics, and they're wondering what else they can do.
Yeah, I think
they're starting to think what to choose between R and Python. So
can you say that again? So I think I should open this Q&A box as well.
Yeah, there's someone who is asking for some courses what do you prefer between R and Python for data analysis?
Well, that's a
I think it's a tricky question.
Yeah, I need to go back to this logical fallacy that I mentioned. I need to go back. This motivated reasoning. Cognitive bias. I use Python a lot, so my bias is towards Python, but actually I use both. But to be more objective, R is more known for, more designed for statistics. It has more deeper roots, but Python is catching up. So whichever you start, you need to pick one somehow arbitrarily. If you're more towards stats, I would suggest R. But then you need to focus on a particular language, especially if you're a beginner. But if you're a power user, you're a more advanced programmer, you know how to program things. What I personally do and what I personally suggest is to exploit the strengths of all these programming languages. I showed you here that, different languages that we use. So we always switch. We always switch between MATLAB, Python, R, and all these based on, one is doing one thing better, the other is doing other better. So it depends on the project. I hope I was able to answer this question. Okay.
Yes. So Yasin is asking for the slides. Yes, we're going to send the content slide after we finish this session. We're sending everything to your emails.
Oh, I hope, Murad, I don't think, I did not want it to connect it to Cobra. There was a sudden unexpected question by, I think, Dr. Masood. I recognize his name. It should not happen. There's no way Cobra effect would, something like this would happen into COVID-19. It's just too critical thing, life-threatening thing. So we should just follow government in a very, very positive way, in the true spirited way.
Okay. I think that's it for the questions. Doctor, do you hear me?
Yeah, I'm hearing you. I'm quickly checking my chat box and my question Q&A box. Yes, I hope I have not missed any question. I really apologize because there were lots of questions. So I really apologize if I missed a question, and you can email me, you can contact me, any one of you, if you'd like to talk more about it. Thank you, Amna. Thank you, Murad. Thank you, Yasin. Thank you, Sadeem, Rawan, Bandar, every one of you, everyone who attended the session. So thanks a lot.
I would love to thank you, Doctor, for taking the time to speak to our community. We truly appreciate people like you who are willing to give their time and talents to enrich the field. Thank you so much. We really enjoyed it. I would love to thank all the people who attended this session. وبعد ما ننسى كمان نشكر مركز ذكاء شريكنا شركة تفعيل في الشرقية، وأشكر طبعا هديل وعبد القادر وكل المتطوعين في الداتا كوميونتي. شكرا لكم جميعا، وإذا عندكم أي سؤال أي استفسار بعد ارسلوا لنا إياه على تويتر، على الإيميل، نستقبل جميع الأسئلة إن شاء الله، ويعطيكم العافية جميعا. I think that's it. Doctor, if you want to add anything, the mic is yours.
Sorry, I muted so that it doesn't, interfere with you, but I couldn't unmute. No, thank you so much. Thank you, everyone. And I'm really thankful to the Sharqiyya data community for inviting me. I hope it was useful. Some part of it was technical, some part was, on different topics. So I really hope that you're at least able to get part of it. And I'm more than happy to communicate with any one of you, in the future. So thanks a lot.
Thank you so much.
Thank you so much, Doctor.
Thank you, Adil. Thank you, Abdullah. I especially wanted to thank both of you. I think you have put a lot of effort in making this possible. So thank you. Thanks, both of you and your whole team.
I would love to thank the team as well. So thank you everyone, and إن شاء الله بنشوفكم بلقاءات جاية. يعطيكم العافية.
Okay, Abdullah and Khadil, inshallah, we'll talk soon, inshallah.
Okay.
Inshallah, Doctor. Thank you.
Thank you. Take care.